My name is Dan Pudwell. I work with Grid Smarter Cities, the logo up in the top left there. We're a startup that's been around for about 6 or 7 years, which is a long time for a startup, but we're just kind of starting to find our way now, and this is one of the things that we've been working on recently. So we built an application in roughly 6 months' time, and it cost roughly £100, so dollars, we'll reveal at the end, for roughly $100 or £100. So I've been a developer architect for about the last 12 years. I also run the Serverless Northeast meetup up in Newcastle. If anybody's in Newcastle wants to join us or provide a talk, that would be hugely appreciated. I'm also the co-founder of a charity called Tech for Kids. We do annual tech days where kids can come around and play with robots and do some programming in Scratch and VR and a bunch of other things. And I'm at Dan_Pudwell on Twitter. Mostly just dad jokes and not stuff about serverless or tech stuff. So today we're going to talk about the project that we worked on, what it was, and the technology that went into it, how we built that, the architecture, and then we'll reveal the build at the end. There's also a surprise section at the end where I'm going to go over some lessons learned about things we discovered as we built it. Okay, so the concept, the project, it's called ADAPT. I honestly can't remember exactly what the acronym is for now, but what it is we're going to help some disabled passengers get through an airport. We're going to help the airports manage how they can provide that assistance to the passengers, and like I said before, it took us approximately 6 months to build this. So if you've seen the news recently, you might have seen some headlines about some stuff like this. Obviously, Thomas Cook, no longer a problem. But places like, well, every airport in the world will do, or has a process where they help passengers get to where they're going. The process, though, isn't very good. So, people are getting stranded on airplanes. They can't get any assistance with their bags when they need it. They get left in places they don't really want to be left in. So it's not very good. So as part of the project, we identified 3 main kind of user groups. So there's a passenger, obviously, who needs the assistance. There's an assistant who physically goes and provides the assistance. And then there's the coordinator who manages all of that on behalf of the airport. So typically, you'll find a service provider in the airport, not necessarily the airport themselves. So for example, Heathrow uses, I can't remember the name now, but they'll have a service provider. They don't do it themselves. So their current journey, this is what they do now, and this is the same almost in every airport. The passenger will have to call the airport beforehand. They'll have to say exactly what time they're getting there, what their requirements are going to be. If they're running the traffic on the way, that obviously messes up the plans. They're not, going to be handled very well from that point on. Once you get to the airport, you have to present yourself to a help desk. If you need a wheelchair, they will take you to a holding area, and you'll have to wait. Then you have to get through security. Then they'll take you to another holding area. Can you imagine kind of, just walking through the airport and people telling you where to stand? And you have to stand there. You can't go anywhere else. It's a horrible journey for people. You can't even go to the toilet or shop, Imagine if airports, how much more money they could probably make, and bars, restaurants, shops, if people could just do what they would want to do, right? So this is what we wanted to do. So this is a little bit based off a project we had a few years ago called Assist Me, which was helping rail passengers. So the concept is roughly the same. As the passenger is nearing the airport, they're going to trigger a geofence. That's going to alert the airport coordinator. Somebody's on the way. This is their details. They have an electric wheelchair. It weighs 50 kilograms. They're going to need some help getting out of the vehicle. They'll need some help with their bags and getting through the airport, security, whatnot. So once they get that notification, that's it. They can just get to the airport. If they need help, the passenger will request it when they need it, not, when they coordinator or the airport thinks they need it. So they get a mobile app. They can just press a button or click on the screen. I need assistance for whatever thing I need assistance for. That coordinator, the person who handles the request, will assign somebody to it. So they'll have a detailed list of who they can assign. So they'll, if it's somebody who's maybe deaf, they need somebody who knows sign language to assign to that person. All of the requirements are matched up. The assistant can then see the person on a map of the airport. So the airport is internally mapped. That's available in the app on both sides of the assistant and the passenger. So, passenger is a blue dot, assistant might have a red dot. They can see each other where they are on the map. So people with anxiety issues, they can see there's a person 200 meters away, and they're actually coming to me, fairly soon. Hopefully keep them calm. We also have two-way messaging, so you can send messages back and forth between the passenger and the assistant. If they just need to know where the toilet is, or a question, how long are you going to be? Don't worry, I'm going to be there in 5 minutes. Just do that through the app as well. So to do all this, we heavily used AWS Service. It was a completely serverless application. So a lot of Lambda usage, Dynamo. Interesting, we also use WebSockets. So I don't know if anybody's played around with WebSockets, API Gateway v2 in CloudFormation. That was a really interesting use case for the real time between passengers and assistants. Obviously, NoSQL with Dynamo. We did some push notifications from the Android app to the coordinator, vice versa. The coordinator application was actually a web browser application, just plain old React. So in that case, we use something called Vapid. I don't know if anybody's come across it, but it's how you send a push notification to a browser application. It's really interesting. We also had the internal mapping, and then we did everything serverlessly. So everybody's probably gone to a few of the serverless talks today, so I'm not going to spend too much time, but my own personal definition is it's an architecture that allows developers to focus on business value instead of the infrastructure management by using cloud provider services. So AWS, Azure, whichever one. Obviously, we do this because we don't care about the servers underneath. We don't care if it's running Windows or Ubuntu, whatever. Obviously, because of Lambdas, we have to know what we're running on, but we don't care what version it is, security patching, auto-scaling, so it can just do that for us. Obviously, high availability, and we only pay for the usage that we're going to be using for. I can't remember where I found the serverless bunny, but I thought that was pretty good. So the architecture of the application was broken into 3 microservices, kind of one large microservice and then 2 fairly small microservices. So the adapt microservice handled all of the business logic for that. And then we had a couple of smaller ones to handle some more of the generic application requirements. So things like sending out push notifications or handling a user's profile. We went with a multi-account strategy as well. So each of those services has their own AWS account. And because we wanted to keep production data and test data separate, we also have a second staging environment. So this means we have 6 AWS accounts for this particular application. Like I said before, we use WebSockets for doing the updates to the client. And then everything was obviously going through continuous integration, continuous deployment. So CloudFormation kind of all the way for that with code build. This might be a bit tricky to see at the back, but that's the architecture diagram. So you can see on the left, we've got 2 Android applications and the browser application. Lots of Lambdas, lots of Dynamo tables. The difference between the blue and the green Lambdas, the blue ones are for the WebSockets. The green ones are just plain Lambdas. Except for, you can maybe see the ones that kind of stream off of Dynamo. That was a really interesting thing that we found really useful. So, when a passenger raises a request, that just streamed off to a Lambda that notifies the coordinator. So we didn't have to involve anything else, no SNS, no SQS, just a nice simple stream off the database. But there's a little caveat to that. We'll talk about that at the end. So you can see the dotted lines are the 3 different services. So we've got profiles, notifications, and then obviously a big one for the actual adapt service. This is kind of how the AWS accounts stacked up. So we use GitHub for version control. You can see, I don't know, taking profiles top right as an example. We have kind of a master version of the code. And then we have a pull request version of the code. So every pull request that gets raised creates an identical environment to its kind of master version. So all the tests can get run. We can do some integration testing. We don't have to deploy it at that point. We can just keep doing some manual testing on that if we want to. However, once it's merged, which is the black line, it merges that version of the code into our master version, and then it immediately deploys as well to our production account. So we don't have any sort of approval process. I think I heard somebody ask a question about that the last talk. So yeah, we don't do that. We don't have change management or anything like that. We just deploy straight to production. So some people might call that a bit dangerous. But if you've read Accelerate by Nicole Forsgren, Gene Kim, I think, helped, and Jez Humble, doing a continuous deployment style like this is much preferred over change management, stacking up changes, and things like that. And we actually found it really, really stable. We had 1 production incident in the entire time we were running our trials, and that was more of a user error than actual buggy code. So the moral there is if you've got really good automated testing for your pull request environment, and integration testing, linting, and all the rest of that stuff, you shouldn't really need change approval or anything like that. Now, here's the fun part. So over the January to July, kind of starting development straight up to the trials, as you can see in the bottom right-hand corner, it costs us $137.48. So it's approximately £100, depending on the exchange rate. As you can see, the highest cost there was actually our test version for our adapt microservice. $91 out of the total 137, so I don't know, what's that, like 3/4 of the cost probably. Running the code in production cost a little bit more than $20. So less than 20% of the actual cost was running code in production. It'd be interesting, I think, maybe to compare this to people who have much higher volumes and much, to see kind of, is less than 20% a normal number, or are we doing something a bit different than everybody else? If anybody has any other numbers to compare, I'd love to talk to you afterwards. I think that would be really interesting. What else? Yes, that's really interesting. As you can see, it stacks up by account as well. So the adapt staging is the big blue one. Again, we kind of expected that from the last table. So breaking it down by service, this revealed some really interesting stuff. So just to build the code cost us $57. So when you compare that to 137, that's almost half just to run code build. It was over 6 months. So if if you're going to run it on Jenkins, on an EC2, you're still going to pay more. So that's still not expensive. But in the context of this, that was our most expensive thing. Just building the code, running the tests, and actually running the deployments as well. So we use code build to actually deploy as well to production. We don't use code pipeline. We only use code build. We just kind of like the more manual nature of putting the stuff into the build spec. It's actually better control. The other thing I found really interesting is if anybody's ever looked at their cost report stuff, tax is actually listed as a service in AWS. I'm not sure why. But yeah, we paid a fair amount in tax. Our Lambda compute cost for 6 months was just a penny. That's pretty good. If it was running on EC2, that would have been, I don't know, probably at least a few $100s over 6 months. What else is interesting in there? Dynamo, $1.45. If you want to run that on RDS, it's probably at least $10 a month, up to about $30 a month, depending on your instance size. So that would have been another couple $100s. So yeah, this was a really interesting breakdown for us. Cognito was 0, so we didn't have many users. We had about less than 100 users. But yeah, it was nothing. You don't pay for the service until I think you hit about 50,000 users, so very good value. And then kind of the breakdown by month, again, by service. So this revealed something really interesting. So you can see there's a bit of a difference there between June and July. So if you look at the code build cost, which is the blue bit, it kind of goes up and up and up and up and up until you get to July. And in July is the time where we actually start running the trials. So you can see we've actually got less building cost, but the green bit is CloudWatch. So we've got less build and more monitoring happening at that time. So I'm not going to get in between you guys and the bar for too much longer. These are the things that we kind of learned as we went through. So there's size limits on API Gateway and Lambda. I think it's about 5 meg. I can't remember, but we were, somebody takes a selfie with their phone using probably a 10, 15 megapixel front-facing camera. That's not going to go through API Gateway or Lambda. So to solve that, we had to basically ask S3 for a pre-signed URL, give that back to the client, and then the client uploads the picture using the URL. There was a really interesting blog post about that. I can share that afterwards with people, but it was one of these photo sites like Flickr or something that uses that approach. So definitely recommend it. I mentioned before about the DynamoDB stream. So if your Lambda fails whilst it's being invoked by the stream, DynamoDB will continuously retry and retry and retry for at least 24 hours. The only way that we found to fix that was actually to tear the stack down and rebuild the stack. Obviously, in production, if your DynamoDB table is in your stack, that's all your data gone. So I wouldn't recommend that. So the way that we solved that, basically you try catch around all of your code and then handle the error appropriately. Unfortunately, there isn't really a better way of handling that. You could possibly use a dead letter queue, but again, you've still got to handle the error somewhere. WebSockets. So I mentioned before we use WebSockets for the real-time nature between the passengers and the passengers and the assistants. So they're really hard to test. It's an asynchronous service, so you send a message in. You may or may not get a message back. You might get a message back, half an hour later when the coordinator does something with that request. So to test that in an automated process is really, really hard. In fact, when we looked, there wasn't actually an automated tool to do this. If anybody does know of one, I'd be glad to hear of it. But we actually ended up writing our own open source tool to do that. I'll share that at the end. The other thing that you might have noticed on the diagram was direct integration with API Gateway and Dynamo. So you can point API, or not, you can call anything after API Gateway. So you can go to the simple email service, you can go to SNS, you can go to Dynamo, you can go to almost anywhere from API Gateway. But it requires you to use something called VTL, a velocity template. Now, they're really hard to write and get right. So you have to kind of go through a process of writing something, testing it, writing it again, testing it several times before it works. And then you can't unit test it. So if it's something there that is maybe doing a little bit of business logic, I wouldn't put that in. That's definitely not the best place for that. Now, the other thing about Dynamo, people might have come across this before, but obviously it's not a relational database. And it's well, sorry, it can be a relational database, but it's very hard. So if somebody wants to know more about relational and Dynamo, there's a great talk by Rick Houlihan, who's an AWS guy. He did a talk at re:Invent, I think in 2017, about Dynamo being relational. But at about the 45-minute mark, you're kind of following it along, and then all of a sudden he goes into like this extra dimensional level where you just have no idea what he's talking about. It's really, really hard, so I wouldn't recommend it unless you know exactly what your access patterns are, your queries. If you think they're going to be changing 6 months down the line, I definitely wouldn't recommend Dynamo. It's really not a good thing to use. I mentioned before about our open source stuff. So we've got PyWSI test. So we've written everything in Python, by the way. That's our WebSocket automated testing library. We've also written something called AWS Lambda decorators. So these are some decorators you can add to your Python functions, your Lambdas, to extract your parameters from your event. It can go to SSM and grab some parameters from there if you want. It can validate the parameters that are coming in. There's a min, max kind of thing, strings and string length. It can also add cores onto your request. Obviously, cores is quite a big issue with Lambdas and API Gateway. It can also do some logging and some exception handling as well, just by adding the decorators onto the function. And then obviously as well, the DynamoDB parser. So when you get some data back from Dynamo, it's not in a nice JSON format. It's got some N's and S's and B's and kind of in front of the values. So this is just a nice little tool to kind of strip everything out and give you a nice dictionary at the end of it. And that's it. I don't think I took up too much time, so probably way less than I was supposed to. Sorry.
Question.
Anybody?
Go for it. Yep.
Hi, I liked your talk. Could you tell me more about the multi-account architecture you decided to go with, why you chose to do that, one service per account, and also whether you would do it again, given the chance?
That bit.
Yeah.
Yeah, cool. The reasons we did this was we didn't want production data mingling with test data. So nice separation there. The other thing as well, so we didn't want to, if it's all in one account, it's maybe a bit tricky if you're dealing with, 15 Lambdas like we were dealing with to find out which one is the production Lambda, which one's your test Lambda. Having it in a separate account actually just makes that a lot easier. The other reason as well is the free tier applies to each account. So that's a tip for everybody out there. Yeah.
I completely understand the separation of staging data from live data. I think I was curious about the service separation and free tier stuff.
Yeah. I don't know if everybody's heard of evolutionary architecture. So we kind of started with a big bunch of stuff and then just separated as we went. So we found that notifications was a nice thing that we could sort of just wrap up and sort of keep separate. It can have its own deployments, it'll be its own service. We kind of had an eye looking forward as well as to other things that could reuse that service. So not just this adapt product, but further products down the line could reuse that service. Same thing with the profiles, although actually what we're finding now is actually that profile service isn't as reusable as we would hope. But the notifications one is definitely. So I think the trick there was mainly kind of any sort of generic action, not like a generic thing, if that makes sense.
Thanks very much.
Yep. Thanks, everyone.